All right. Oh, Ruth, you are in here. Okay. So I'll try to stop a few minutes ahead so I can kind of see what's happening, okay, with yours. All right. So inside here, you should have this available. Read Unit 3 and MindTap and take the Unit 3 test by the due date, which I had students tell me it closed last night instead of tonight, so I went in and changed that. So if you did not get a chance to take the Unit 3 test, then you can still take it before midnight tonight. Then these are a couple of the scripts. Oh, these were from Unit 2. I shouldn't have put those up there. I don't know. And you were supposed to complete the next video, more on variables. So this, but you'll still have time to do that. Let's see. I'm gonna mute you for a second, Rick, and then you can unmute if you need to ask a question. Let's see, where did this go? All right, so those learn, go to assignments here. The more on variables is the video of the guy called Learn Python. So this one was out of module 2, and it's also due by midnight tonight. So those two things you need to get done. He's the one where you do the watch him and type in the Python. That he's the one that, you know, because in our book doesn't really teach you Python. It just has you do all those MindTap assignments. So this is a little more on variables. But does anyone need me to go over anything on the test? Everybody do okay? You checked your grade. I think I did audio critiques on all of them. If you, where I told you if you did anything wrong. If you got 100%, then I probably didn't tell you anything. All right. So today, then we want to go into Cengage. And look at chapter 3, and then I'm going to talk about the book that's the PDF called Head First. Did you have a question, Quadri? Yes. Does anybody else not have theirs graded? Well, y'all didn't. Let's see here. They should all be graded. I know, maybe I just graded the online. I thought I graded. Let me go to this section. Huh, you're exactly right. I did all the online and not y'all's. Okay, so here's what I'm going to do. I'll go ahead and we can look at, let's see, who thinks they got theirs all right? Anybody want me to open it? See? No? Anybody? Because I can grade yours right here. See? Alan's not here today. Nicholas, Blake, Tishan, Joseph. Yours probably, you think yours is pretty good? Your test? Is it okay if I open it? Yeah. Okay. Let's look at yours. Let's see. And then that'll show everybody. Then I'll go back and grade. Because it doesn't show score. No, I didn't grade it. I didn't. I just realized I didn't click on the lecture class. I graded all the online section. So here he submitted all 3 of the documents for points. And let me bring up the rubric for the test too here, so we can see where the grade comes from. Spring. Oh, there it is. Fundamentals. Okay, so in this document, the first thing, the pseudocode and flow chart, if you used constants and used the right symbols, then, and the logic, of course, was right, then you got 13 points for each, and then 4 points if you named it as a PDF, which he did right here, T1 JJ PDF. So let's look at that document first. And here he has start, His declarations are using constants, which is what was required to get 100% of the points. Some students, I went ahead and gave them 100%, even if they did not use all caps, because that's not a requirement, but you need to get in the habit on your constants of using all caps. So these are constant variables that he named. You should have had only one input, which was credit hours. And then your calculation could be in 2 statements, or it could have been all in one. He did his here in 2 statements. Credit hour rate equals credit hours times semester hour rate, which is this constant. And then he used that result to create the second calculation. You could have just simply said total bill equals credit hours times semester hour rate in parentheses plus semester fees. So either way is correct. And then output total bill. All right, so, and here is the pseudocode, and this is very straightforward. This is all that was required, and this is, the pseudocode should match the variable names and all that are in your flow chart. And you'll notice he used a rectangle for the constant, parallelogram for the input, a rectangle for the calculations, and then another parallelogram for output, and then a stop. So I had a couple people I know on the online that didn't use the correct shapes, and that's important in the flow chart. That's why this first test, I'm having you do both flow chart and pseudocode. But you'll notice the text, actually, if he did pseudocode first, he could just copy this into the correct shapes. All right, any questions over that part? Okay, the next part of the test, you had to create the Python, and you were supposed to upload the Python. And so here's his Python. And if you didn't do comments, I did not require it this time. But if you get in the habit of doing that, then later on, I allow you to do just comments if they're a little more detailed than this, but instead of the pseudocode. So here he did exactly what he did in his pseudocode. One of the requirements was that your variables match the names that you used in your flowchart and pseudocode, which he did here. And then he printed out, this is not his input statement, he's just printing out to the screen. And this I didn't count off if you did not do this, because I didn't tell you you had to, but this is good coding. The semester hour rate is, and then he put what that hour rate is, and it'll print to the screen. Print fees are, and so those are 2 statements that if you didn't put those print statements, you're still going to get credit for it, because I didn't tell you to do that. Then input is credit hours equals float. Now, why did he have to do float? You either had to do it there or you had to convert to float. You could have done it as credit hours as an integer, and then when you output or convert that field there to a float. Because float, he's doing because he's dealing with money, right? And money, you have to use a decimal point and two decimal places to be able to print out money. So then credit hour rate, these are the exact same 2 calculations that he did in his pseudocode. They didn't have to change at all because he used the variable names the same. And then he printed the tuition is $ plus string total bill. Well, because he used float here, then total bill was a float, so it had a decimal point in it. But when you print it, you have to change it to a string. So that's why he did that. And then thanks for using our website. So this, instead of, I could download this and run it because some people did not include their screenshot, and that took 2 points off. But if you included your screenshot, which he did in PyCharm, and you won't be able to see it very well because it's pretty small, but this is his Python running, and here this shows me his output. Let me see if I download it. I can see it better. Here. Put it in preview mode. Okay, you can see it a little better now, but so his output, when he runs his program, those two print statements at the top print this out. The semester hour rate is $79, and it just says 79.0 because you have to actually put a format 2 decimal places to get it to do that if it's a 0. Fees are $21.75. That comes from his second print statement right here. And then his input statement says, how many credit hours did you take? Right here, how many credit hours did you take? And he entered 12, which is what I told you to use as a test value. And then he has his output statement. The tuition is $969.75, which is correct. And he formatted it with the $sign and the decimal points. So therefore he gets 100%. Okay, anybody have any questions? So now you kind of know what yours was, but I'll go back and grade those tonight, okay? But if you got that output with the $sign and the money decimal points, you got 100%. If you left something off, you know, I detailed out how many points for each thing was on there. So anybody any questions about the scoring or anything? Everybody's okay? All right. So now let's go back to Cengage then. And let's look at Unit 3, what we're going to be covering here. I know I had some online students that had some questions because they tried to do the MindTap problems. And they had a problem with the modular one, I think. Okay, so Unit 3 is all about structure and modularization. And so if you haven't looked at chapter 3 yet, you're going to do it today and do the test tonight. Well, here is the part that is covered. The chapter is going to talk about the difference in structured code and unstructured code. And when I started programming in 70, 79, something like that, I started in a language called COBOL, and I had to maintain other people's code, and they did not have structured code. It would be going down a certain, maybe 10 statements, and then all of a sudden it would say, go to the bottom. And that's called spaghetti code, unstructured code. And so we've seen examples in chapters 1 and 2. Here was an example well, you can look back at that because it's not going to take me right to it. But programming statements that look like they're all going from here to there and down, that's really hard to follow. And it's called spaghetti code because it's like a plate of spaghetti all curled up. So programs that use spaghetti code logic are called unstructured programs. That means they do not follow the rules of structured logic that you're going to learn in this chapter. So here is some examples. They use simple activities. You know, you may think of logic as all solving number problems. But everything we do every day, and we've talked about this before when we went through, I think it was chapter 1, they talked about, I think it was directions to go somewhere. You get up, or things you do in the morning, you get up out of bed, you go to the shower, whatever you do, the steps you do, you don't even think about it, but they are logical steps. And so here they're going to use an example of washing a dog using spaghetti code logic so that you can see what that looks like. You'll notice in the flow chart, it starts out and it says, catch your dog. Does the dog run away? Yes. Then catch the dog again. Does the dog run away? No. Turn on the water. Does the dog run away? Yes. Turn off the water, catch the dog. Does the dog have shampoo on? then you come back down here, and it just, you can keep going around and around, and that's why it tells you don't do it. This example does not use good programming style. By the end of the chapter, you will know how to make this example structured, which will make it less confusing. You might be able to follow the logic of the dog washing process because you might already know how to wash a dog, and the flow chart contains a limited number of steps. Imagine, however, that you were not familiar with dog washing, or that the process was far more complicated. Then maybe you must wash 100 dogs concurrently while applying flea and tick medication. All of that, that would be very confusing in those steps. Say you're, from someplace that you've never owned a dog, or you don't know the process, then that would be very hard to follow along. So these are just some of the disadvantages. So the three basic structures, and this is what is going to be in our MindTap problems, and these three structures are what we're going to work with all semester long. If you learn these three structures, and then you can take these three and make combinations of them inside other combinations. Like if you have a sequence, a selection is, like if you're going down the road and you come to a fork in the road, you got to make a decision. Do I go right or do I go left? Well, that is inside the sequence. And then there's a loop. So these three things are the three basic structures that we're going to be dealing with and learning how to code in pseudocode and flowchart. And we're going to use those three structures to solve any problem that we get. So here's some examples. The first one that we've been working with in test 1, all we used was a sequential structure. We established our constants, then we got input, and then we did calculations, and then we did output. So there was no branching or selecting of which direction to go, and there was no loops. It was just simply a sequential structure. And every single program you code has to have a sequential structure. Now, they don't always have to have a loop or always have to have a selection or a branch, but they always have to have a sequential structure from the top to the bottom. And see, some people, when they start doing their flowcharts, they try to make them go across, which you can whenever you start doing branching, but a sequential structure should look like this. It starts somewhere up here and it goes one right after the other. No branching, no looping. So that's how the flowchart would look. So as an example, driving directions often are listed as a sequence. To tell a friend how to get to your house from school, you might provide the following sequence in which one step follows the other and no steps can be skipped. Might say, go north on 1st Avenue for 3 miles. So this kind of looks like a GPS, right? Turn left on Washington Boulevard, go west on Washington for 2 miles, and stop at 634 Washington. Okay, now if you took these out of order, you wouldn't get there, right? Wouldn't work. So this is a set of sequential instructions. The selection structure, sometimes referred to as decision structure, is shown in figure 3-3. Now this is going to be the first time that we're going to use a diamond shape flowcharting symbol. Some people tried to use it in the test. And you don't use the diamond shape symbol unless you're making a decision and saying, do I go right or do I go left? So this selection or decision structure is also called a Boolean expression. Anybody know why? Ever heard of Boolean in math? Alan? Yeah. You've heard of it? What, do you know where it came from? No. No? Well, it's a capital B, so it kind of gives you an idea probably that this is somebody's name. You know, in mathematics and in most things, they're named after somebody. There was a guy named Boole, and he came up with calling a decision that has only 2 answers, true or false, yes or no. That evaluation It's called a Boolean expression. And if you want to see what the exact definition, it says an expression that represents only one of two states, usually expressed as true or false. So if you evaluate a statement and you say, is it true or false, then it's a Boolean expression. True false evaluation is natural from a computer standpoint. How many of you guys are engineering students? Okay, then you will understand this. In the circuit, in the engineering field, every circuit, it's got zeros and ones or on and off switches. The switch is either off or on. If it's off, it's a 0. If it's on, it's a 1. So even though we think we're coding in a language, when we code Python, it's still not computer language. The computer has to interpret, the browser has to change it to zeros and ones, because that's the only thing that the computer understands. Now, when we used to teach logic, and there is in your appendix in this book, a section on binary math. Bi means what? How many? 2. So binary math is where you do all math with just zeros and ones. And you might remember in elementary school when you had to learn place value, that's what it's all about, whether there's a 0 or a 1 in specific placeholders that go 2, 4, 8, 16, 32. Those are bits. And then there are 8 bits in a word, and then there's a full word, it's called. And so the computer, we are very fortunate. When I started coding in assembler language, I had to know the register names. I couldn't use variable names, and the registers would hold zeros and ones switches. Either they would hold a full word. So nowadays, even though you might think programming is a little difficult compared to what we started out with, just switches and having to communicate with the computer that way in its machine language was a lot more difficult. So a Boolean expression is used to control every selection structure. So here is the other flow chart representation. We have sequence where it's just 3, it just goes straight down, right? Then we have selection or a decision structure. And even if you have some sequential symbols going on up here, when you get to the decision, you always have a diamond shape, and the yes goes to the right and the no to the left. Now, some instructors, teach that it can go either way. No could be on the right and yes on the left. But it's very confusing if you don't have a standard way of knowing that it branches to the right means that this statement that you put in here and you evaluate is true, then it would go to the right and it would only do what's in this box. And then it would meet again down here and it would never get here. If this statement is false, then it would go this way and come down, right? So this is the selection structure that you need to remember for flow charting. Anytime you have a decision to make. And here's the mathematician that I was talking about, George Boole. He's the one that came up with these logical selections and he used common algebraic symbols. So a flow chart that describes a selection structure begins with a decision symbol that contains a Boolean expression. That means it's a comparison, and it'll say, is this variable equal to 55, or is it greater? And so whatever the expression is in that diamond shape, that's what tells you whether you're going to, which side you're going to do. So here's the pseudocode that is the same as that flow chart right here, this structure. Here's how it would look. If some condition is true, then this is the true branch. Else, this is the no side, do this other process. Okay, this is just a template for what your pseudocode would look like. For example, here's a concrete example. If traffic is backed up on Washington Boulevard, then continue for 1 block on First Avenue and turn left on Adams Lane. Else, if this is not true, it's false, then turn left on Washington Boulevard. So you understand you can't do both this one and this one. You're going to select one of those two based upon this condition. Do I understand? Okay. So if you've done any coding like with Microsoft Excel, you had formulas where you had to do if then else's. Here's one on a simple, similarly a payroll program might include a statement such as, if hours worked is more than 40, then calculate regular pay and overtime pay. Else, just calculate regular pay and end it. Make sense? That's how you calculate payroll. So then these if-else examples can also be called dual alternative ifs or dual alternative selections because they contain two alternatives. The action taken when the tested condition is true and the action taken when it is false. That's why it's called dual, because it has two options. There are cases, okay, in this one where this if statement only has one option. If it is raining, then take an umbrella. End it. So if it's not raining, there's nothing to do, right? There's only something to do if it's raining. If the employee participates in the dental plan, then deduct $40 from the employee's gross pay. If he's not in the dental plan, then we're going to end. There's nothing on the no branch. That's called a single alternative. And here's what it would look like in the flow charting. It only does something on the yes side. If it's no, it doesn't do anything, right? Okay, the third basic structure is a loop. The loop structure is shown in figure 3-5. A loop continues to repeat actions while a tested condition remains true. The action or actions that occur within the loop are the loop body. In the most common type of loop, a condition is evaluated. If the answer is true, you execute the loop body and evaluate the condition again. So a loop actually has to evaluate a condition, just like the selection structure did. But it's different because instead of just doing one action, it's going to loop. It's called a while loop is the one that we're going to be using. There's a while and an end while. And looping is sometimes referred to as repetition or iteration. That's the same thing. So here's what a loop structure looks like. You still have the diamond shape and you say, if there's still more records, yes, then do this process and come back and test again. Because in this process, you have to do something to change what you're testing. But you'll notice the difference is in a loop, the no branch comes down at the bottom. If it's just an if statement, the no branch is going to be over here. So the while loop tests a condition before executing the loop body even once. And we're going to do more on loops in chapter 5. Some programmers call a while loop a while do loop because it fits the following statements. We don't really have a while do in Python, but some languages do. That's why it's got this here. So here's an example of a while loop. While the address of the house you are passing remains below 634, travel forward to the next house. Look at the address on the house. Test again. Is it below, below 634? If it is, then you're going to do this again and look at the address on the house until you get to 634, then you'll end the loop. Isn't that what you do when you're driving down the street trying to find an address? You look, if it's still below that number, you're going to go forward and you're going to do the same thing again. That step is a loop. Here's another one that we encounter every day. While you continue to be hungry, take another bite of food. Some of us take a bite when we're not hungry, right? We just eat. Determine whether you still feel hungry. If you do, take another bite until you're no longer hungry. End while. Here's another little while loop. While unread pages remain in the reading assignment, read another unread page. Determine whether there are more pages to read. So those are simple activities that are a loop. And when we do a problem, it's going to be the same type of thing as what you do in normal everyday activities. So combining structures. Now, when you go home, you might want to watch this little video clip because this is the author and she explains, it's showing you examples, but we're not going to do that in class. So all logic problems can be solved, just like I told you a minute ago, by using only 3 structures: sequence, selection, and loop. Okay? But the structures can be combined in an infinite number of ways. For example, you can have a sequence of tasks followed by a selection, or a loop followed by a sequence. Attaching structures end to end is called stacking structures. So here's an example. Step A, go to step B, which that's a sequential structure, right? Going from A to B. If condition C is true, then do step D, else do step E. That's selection or decision. Then if condition F is true, then do step G and loop back and test it again and then go out. So that's called stacking. That's all 3 structures stacked one on top of the other. And you can have a program that is just like that. Whether you are drawing a flowchart or writing pseudocode, you can use any opposite, naturally exclusive words to represent decision outcomes. For example, you can say yes or no, or true or false. This book follows the convention of using yes and no. So here is the pseudocode for flowchart and pseudocode showing a nested structure. So you can take a sequence nested with a selection, which what nested means is it's inside. So we've put a sequence inside the yes side of our selection. Is this one a single alternative selection or a dual alternative selection? Is there anything on the no side? There is. I have you doing something on the no side? No. So that means this, you look, there's only an if and an end if, there's no else. So that means this one only has something to do if this condition H is true or yes. You only do these steps if this condition is true. So here's another one. This is another nested structure and it has a loop nested. So here's my if statement and it starts out with a sequential step. Then it goes right into a loop that's nested inside the if. You see that? It's the way you can tell it's nested is by indenting it like that. Code doesn't require you to indent, but Python does. Python's really finicky about indents, but most languages don't care. But it does make more sense because you can tell that this while and end while are inside of this if statement, right? So the only way you can get to this while loop is if this condition is true. Otherwise, it's not even going to do the while loop, right? You can tell that here. If it's not on this branch, if it doesn't go yes, then it's just going to drop out. Questions? You see? All right, so we're going to go and do it with numbers. Here's even another nested one. Look at this one. Okay, and this is where sometimes students can see flowcharts easier than they can pseudocode, because you notice all of this can only happen. See, this if goes with this end if. So there's no else for this if. But look inside here, there's a nested if else. So this is a single alternative if. This particular condition here, that's part of the loop, it's a dual alternative. It's getting a little more tough, huh, to follow. So you can have all of these, some of your programs, you're still just using these three basic structures. Just always remember when you're flow charting that this is sequence, and you might have one of these stuck right in here before this second sequence box, just so these connect and exit at the same place. So here is, I think that we should be about to the summary. Oh, no, let me see. Okay, using a priming input to structure a program. This part we're going to see with actual values whenever I give you the head first assignment. But right now, here's what a flow chart would look like that has, they're declaring the variables. Now remember, in Python, we only have to actually declare if they're constants. But you can do this, it doesn't hurt anything. It's saying my variable, I have two variables, original number and calculated answer. And I'm declaring them both to be numeric. That's what that shows you in the book. So I'm starting my sequence. I come from my start to my declarations, then to my input. Now it says don't do it. This logic is not structured. Why is it not structured? What do you see different in this loop than the ones that we were looking at before? Where does the yes need to go? To the right, because this is coming out with a stop out to the right. There, it should be the very last thing at the bottom here. And so that's why these need to be switched. So these two flowchart symbols would have to go over here. So let's look at another one that looks a little different. It says, beginning of a number doubling chart. So here's what we're going to make a number doubling chart. Input original number. If you're not at EOF means end of file. In other words, if you don't want to enter any more numbers, yes, you're at end of file, then that's what it was saying. Go here and stop. And if you're not, then you're going to have to loop. Let me see if I can find. I don't like the don't do's. Those, I don't like to get those in your head. Don't do that. Don't do that. Okay, here's a structured flow chart. Here's for number doubling. So what does number doubling mean? We did a problem like that. All that's saying is ask for the user to input a number. Say they input a 4. Then we want it to double that number. So we want it to 2 times whatever number is put in and put it in the answer. That's what it's talking about. So that's why it needs an original input number. Then it needs a calculated answer. Now priming, you guys, have you ever heard of priming an engine before you start it? You pump the feet. Y'all don't have to do that because you don't have clutch cars. We used to, when we had clutch cars, you had to pump the gas pedal and get the gas in the engine before you could actually start it. Well, that's what priming is that you've got to get something into the variable before you can start the program and test the loop. So you say input original number. You're going to ask the user to input a number. And so you say, are you done yet? No, because I have a number in there, right? So I'm going to calculate the answer by original number times 2. Then I'm going to output the number. And then I'm going to come back and loop here. So before I can do that, I'm going to have to ask the user for another number. Otherwise, if I don't, it will just keep looping with that same number over and over. And when I no longer put a number in here, it's going to stop because I'm at the end. We're not going to talk about that one either. Okay, these are some of the reasons for structure: clarity, professionalism, efficiency. I'm going to let you go back and read these because I don't want to take time to do that. I want y'all can read. So if you have questions on Wednesday about anything in this chapter that I didn't cover, you be sure and let me know, because I know most of you probably have not read the chapter yet. So go in and read that. So what we're going to spend the rest of the time doing is we're going to go into MindTap so we can work these code together. So if you haven't signed in yet, you might want to do that, or you'll have to do these on your own. Okay, so let's go into Cengage code. We're going to use flowcharts and pseudocode in Python. Start the assignment. Okay, in this lab, you use the pseudocode in figure below to add code to a partially created Python program. When completed, the college admissions officers should be able to use the Python program to determine whether to accept or reject a student based on his or her class rank. So it says, here's the pseudocode. Start, input the test score and the class rank. Let me move this over a little. If test score is greater than or equal to 90, so this is going to be a selection statement, right? It says if test score is greater than or equal to 90, then this is the yes side. If class rank is greater than or equal to 25, then output accept. So both of these statements have to be true in order to get an accept, else you get a reject. Then you'll notice this else, this is a nested if then else inside this if else, which says if test score is greater than or equal to 80 and class rank is greater than or equal to 50, then accept, else reject. Else if test score is greater than or equal to 70, if class rank is greater than or equal to 75, then accept, output reject, end if, else, output reject. You'll notice here at the bottom, there's 3 end ifs. That's because for every if statement, there has to be a matching end if. So the end if for this one is in line right here. But this if statement, the end if is way down here. So it doesn't end until there. Now they've coded this one for you. Here's what your instructions are. Study the pseudocode in the picture above. Write the interactive input statements to retrieve a student's test score. So here is where we're going to do that. Get input and convert to correct data type for test score and class rank. So here we're going to say we want to get test score string. So we're going to do this in 2 statements. We're going to convert it. So we're going to say test score string, because that's what it told us to call our variable, right? Is equal to input. And then we have to ask the user, what does it tell us to ask the user for? Up here in our pseudocode, did it give us exactly what to ask? No. Okay, let's just say, please enter a test score. And then we'll put a period. All right, so that's going to do the input for that one. Then it says a student's class rank. So let's do that one. It says to call the variable class rank string, because remember, as it comes in, it's always a string. Input please enter the class rank. Okay, now step 3 says write the statements to convert the string representation of a student's test score and class rank to the integer data type. So they're actually doing it in 2 steps. So here we're going to say, my cursor's outside there. I'm going to say test, they said to call it test score is equal to integer test score string. Okay, so it's going to take what the user entered. Value is inside test score string. It's almost a tongue twister. And this statement will convert it to an integer and place it in test score. So now I need to do that for class rank. So what would I put here? What did it tell me to use? This class rank. Be sure I spell it just like they did or it won't find it. Equals integer class rank string. Okay, execute the program because the rest of it's coded for us. So they went ahead and coded all of that pseudocode like this for us. So now we're going to run it and see if it works. And it gives us some values. It says enter 87 for the test score and 60 for the class rank. And then it should show us, oh, actually we can do that over here. We'll do the check. Student, see if it's rejected correctly. And I got a green. Student is accepted correctly. And I got a pass. So I can submit it. But if I want to see how it runs, I would put 87 and class rank was, what did it say, 60, I think? Accept. So it was accepted. So now they tested it with something. Let's see on reject what they do. They used 60 and 87. So now if I run it again and I do it backwards and I say a 60 and an 87, it should reject, and it did. So that's why I got 100%. Everybody able to get that? Anybody need help? Okay, so we're gonna have time. Ruth, did you do all right on that or are you doing it? You are doing it? I'm sorry, I had you muted.
My screen won't let me do both at one time. It's only letting me do the Zoom meeting. I can't do that.
Oh, okay. All right. You can minimize the Zoom, but I'd have to show you how to do that, where you could do it. Okay, so let's see. So now we're done with this one. We're going to close it out. And you can go back and watch that, though, if you have trouble. Okay, so the thing that, and when my online students watch this too, that you have to be careful of is putting spaces in the wrong places, but it's not going to give you as hard a time with these first two. So now we're going to write a modular program in Python, which one of my online students had trouble with this over the weekend. He sent me an email. I don't remember who it was. Okay. In this lab, you add the input and output statements to a partially completed Python program. When completed, the user should be able to enter a year, a month, and a day, and the program then determines if the date is valid. Valid years are those that are greater than 0. Valid months include the values 1 through 12, and valid days include the values 1 through 31. So here's our instructions. Notice that variables have been declared for you. These are the declarations. It's saying valid date is going to start out being equal to true. And these are all constants, see, because they're all caps. Minimum year is 0, minimum month is 1, maximum month is 12, minimum day is 1, maximum day is 31. So we're going to write input statements to retrieve a year, a month, and a day from the user. So here, these variables are also declared and set to none so that there's nothing in them right now. So we're going to say get the month, then the day, then the year. Include the print statements to output. Okay, so we're going to write input for the year. So we would say year equals input. Please enter a, did it say a 2-digit year or a 4-digit year? Did it tell us? Valid years are those that are greater than 0. I can't remember if they want 4-digit or 2-digit in this one. Integer year. Okay, we'll just say, please enter. Thank you. Okay, I'm gonna do it one more time probably. Okay, so here I'll just say, please enter a, I'm hoping that it's a 2-digit, I can't remember. Should, but I don't. 2-digit year. And so then I'm gonna say, what's the next one? Month, I think. Yeah, month equals input. Please enter a month. Oh, I didn't mean to put that in all caps. It might not let me do that. I better change it. Okay, and I have one more input field, is day equals, please enter a day. Now, housekeeping says, include the print statements to output the following. Month, day, year. Let me see what this is saying. What's that? Oh, thank you. I forgot to put input there. That won't work. All right. So this is a, let me close this part so I have room to see this. Okay, here's what I'm supposed to type in. Month, day, year. I'm supposed to make 2 print statements that output the following. Month, day, year is a valid date, or month, day, year is an invalid date. So they already did it. Check to be sure date is valid. If integer year is less than or equal to, there's something has to go right there. Hold on, let me look. I gotta find out for sure that I'm doing it right. So somewhere there. This is 3. What's the name of this program? Is it college admission or bad date? Okay. So I'm find for sure that I've done it right. Was enter year, enter month, check to be sure date. Oh, okay. So here's what it wants us to do. I remember now. I'll put this. Okay, so the print statements. Did they put the print statements down here? No, here's what they're wanting us to do is this output statement. So if validate is true. Let me look at that open again. So here's what we have to code. If validate is true, this is the output statement. So you can see it better there probably than you can even in mine. So you have to say print in parentheses month plus, and in quotes that slash that's underneath the question mark on your keyboard, plus day plus slash plus year plus is a valid date. Else you want to output that it's an invalid date. So this is a dual alternative if at the end. Here's something that I need to show you too. That's a Python thing, and it's kind of confusing. This elif is really just an else if, but in Python you can do a shortcut and say else if, and that's what these both are, elifs. Now, any of this in Python that you don't get, I would go out to W3 Schools and look at what an elif and an else if is. Tell me when you've got those copied in. I'm going to go ahead and make mine work. Y'all still typing? Let me see if it will let me put it there so you can still see it. Okay, that's that one. Let me scoot it over so you can see. That's that one. If you're in the far back, I think that's Carson back there, you might not can see it, but you can. Here's the second one. I'm going to put them in there so I can see if they work. Now, it's important in Python that you indent like this is. So those are the two statements that we should have added. So now let's see if we got it right. Prompt user for year. Let's see if it's going to let me do it with the please. No, it gave me an error. It probably wants me to just say enter a year. I'm going to come up here and say enter a year. I think it puts a colon there. And this is going to say enter a month, and it's going to want a, pretty sure. That's why I do these in class, because it's kind of picky about this stuff. Enter a day, colon, space. And let's see what happens now. Still doesn't like it. Let me see what it's saying. Code pattern incomplete. It doesn't like something. Searched your code for a specific pattern. Oh, it's wanting the dot. Let me look. Okay, something I didn't do right. Must not want the colon. Let me look again. Oh, it doesn't want the A. Huh. Enter space year. You can actually, anything that's in quotes, if you were in idle or PyCharm, it would work. But in MindTap, it's looking for this exact expression. So it's even got a single quote, but I think it'll work with double if I just say enter year. And enter month. Enter day. Let's see. Is that what it looks like? We'll see. I think that would do it. Okay, let's run the check again. Blake, did you? What did I not do? What did I leave?
I don't think you folded
Down here?
Yeah, he did put the $3.
Yeah, I don't know. It's given me this one, code pattern, prompt user for year. So it's thinking that I'm not prompting them for year. Did you get yours right? Did yours run? Okay, do you see where it's doing anything different? Let's see. Who else got theirs to work? Should say year dot about. Maybe, did you use double quotes?
No, I worked the first time.
Okay, I'm gonna do this and see if I can make it work. Here. Anybody else get theirs to work? No? Just, did you get yours? Did you get yours to work?
Yeah.
Did you do it like this? Let's see. Okay, I don't know. I copied and pasted. It looks like maybe I needed spaces between my equal signs, but you don't when you do Python. You really don't. So that one passed. Let's see if I can get the, and invalidate produces correct. Okay, that one worked. Okay, finally got them all. Okay, so if you need help, let me know. We'll go back and, do you want me to scroll down? Oops. Also, I can do it in idle and it might look easier. This might be easier to read because it's bigger. There they are. My computer's about to die. I can tell. Oh, it did before I, hold on. There it is. Now, let's see, we only have 10 minutes left. So I want to show you the other assignment, and you can go back because I'll upload this video. So if you can't get it to work, you can look at them exactly. I also can post this where you can just copy and paste it in there like I did. But the biggest thing about this, why they wanted you to do this bad date one, is the use of the if-else's to see how that works in Python from the pseudocode that they gave you. So that's why, what the purpose of these particular exercises are. I think that's the only other coding one. Yeah. Okay, so I want to go back to this other assignment. So if you didn't get it working, I can even help you some after, but I got to stop a few minutes early to talk to Ruth. So let me go back to Canvas, and let me show you one of the other assignments that's in there for Module 2. After more on variables, Unit 3, these are the two we did today. There's an assignment called Head First, Chapter 1. Oh, these have up till next Monday. I didn't know that. Okay, and this, I don't know why that says February 24th, and that's not correct date, so I'll have to go in and fix those. Those shouldn't be there like that. I'm not even sure what that is. Okay, so these are the ones that we're going to work on. And first of all, you've got to read and take Unit 3 tests tonight before Wednesday. But this is from that PDF book called Head First. And I'll open it up here in just a second. You're to read from pages 1 through 25, and it's not like reading in the Cengage book. If you've looked at it, mostly each page has a lot of pictures in it. So you'll read those, and if you have the PDF, It's page 61. The pages, if you actually go and get one of the old books off of Amazon, it's very cheap because it's an old book, then it would be page numbers 1 through 25. So the PDF's a little different. As you read, complete the Python program from the guessing game. Run the program and test it with the values as on page 25 or 61. Upload here 2 files, the Python file and a screenshot showing your test run. So let's look at this and I'll show you how this goes, because the answer is actually in the book too, but for you to see if you understand it, you need to try to do it first. Okay, so this is what the book looks like. Head First Programming, a brain-friendly guide. And so you'll notice this book is really different. But if you're starting to code in Python, this is telling you how to write programs using Python and some of the thinking that you go through. Programming lets you do more. What do you mean? That's not the way the website was programmed. And so it's things that maybe some people really relate more to a textbook like this. This used to be the only textbook I used, but I had a lot of instructors that said this isn't a textbook, so they wanted me to change textbooks. So I still use this because it's free, and some students it helps you understand better. So if you go through here, this is saying sharpen your pencil, write the code. This is a guessing game. Study it carefully and opposite each line of code in the program, write down what you think the code does. If you're not sure what a particular line of code does, don't worry, but try to guess anyway. One line has already been done for you, and there'll be like notes throughout. So this is the Python for a guessing game, and over here it's telling you to write what you think is happening. And then the very next page has the answers for you. Okay, and then down here it's telling you G equals input. Well, we already know how to write an input statement. And here's the conversion, like they used in MindTap, right? They used a conversion instead of putting int out here like we were doing. So how do you run code? Using an interpreter. And in this book, they're not going to use PyCharm, they're going to use idle, but you can do the same thing in Python. So you're going to create this program and you're going to type this in and you're going to run it and you're going to get to see what happens. We'll go over it a little bit if you haven't. I would like for you to try it before class Wednesday, but if you don't, we will go over it some, but the more you do outside of class, the more time we can spend doing problems. So I want you to go through chapter 1 and write the code, and at the end you'll have the code before at the end. You always know you're at the end of the chapter because it shows you these little sticky notes, what you should have learned in that part. Yes.
I have a question about the grades. Last week you put in 2 grades and the due dates haven't come up yet. But you put 0 in.
I didn't put them in. It automatically does it if I had the dates wrong in there. I'll go back and check it. But I know that can be devastating if you see all those zeros. But ones that I haven't graded or the dates, I just noticed that I had those due dates wrong. So I'll go back and fix those. But thanks for asking, Blake, because I'm sure others had that question. Okay, anything else? Okay, I'll see you guys on Wednesday then. All right, Ruth. I needed to see if you're, because I know there's something wrong with your computer. Or you need to, do you have a laptop?
Yeah, I do.
Okay, is there, are you at all, do you ever come to the school?
Yeah, I do. I have a math course on Tuesday and Thursday, so I do come to school on that day.
What time is it? Because I don't come in on Tuesday until usually
Just at night, about 7:30.
Oh, okay. Well, Tuesday would probably work if you could come before your class. Well, I have a class 5:40 to 7. So your class is 7:30?
Yeah,
Doesn't start till
7:30.
7:30?
I'm sorry, 7:05.
Yeah,
7:05.
7:05. So I would have to have you come maybe say 5 o'clock, if you could, and we'll look at your computer because we need to find out what's going on. I need to help you.
I think the biggest issue is I have Windows 10 and
That's okay. It should still run correctly on there. Okay,
so Tuesday or Thursday, which day?
Tuesday. If you can come Tuesday at 5, because on Thursday I'm only here for 2 hours in the morning real early. Okay, so Tuesday at 5 would work.
Which building is your office located?
I'm in the business building. It should be right across the breezeway from where your math class is. It's the business building and it's office 114. It'll have my name, Donna Wilson, on the door.
Okay, I'll see you then.
All right, Ruth. Uh-huh.